Hi everyone, welcome to my YouTube channel. Today we are going to talk about DC motor. We are going to talk about how armature affects the speed of the DC motor. So we're gonna run it on MATLAB Simulink. So if you are new here, once again click the subscription button and like as well. So we have our MATLAB open. We go to Simulink. We open a blank model. We maximize it. So for an armature speed control DC motor, we need two voltages. We need armature voltage and field voltages. So all those voltages are DC voltages. So we type voltage, DC voltage source. We need the first one. We need the second one. We copy and paste. So our DC voltage source 1 will be our field voltage, and this one will be our armature voltage. So now we need a DC motor. So we type DC, our DC machine, this one. We need a torque. A torque is to control the speed of the rotor of a DC machine. So we type constant. This is our torque. We connect our torque here, right? We need a gain to convert the rotation of the motor, the measurements of the rotation of the motor, which is in radians per second, to RPM, revolutions per minute. So we do that by dividing. Our gain should be 60 seconds, which is 1 minute, divided by 2 pi, which is equal to 1 complete revolution. So 2 pi is 2 star pi, and put small letters, and then we close our bracket, and then we get our number here. We click apply. Whatever you can put in matrix UK, vector, KU, whatever you want, element wise, and then we apply. Okay, now we need a UX here. Here we need it to have 4 terminals or 4 outputs. Okay, we need a display which is in the form of a scope. We need our scope to have 4 input ports. Apply. Okay, let me maximize our scope like this. So we need to connect our field voltage source to the fields, the positive of the field voltage source to the positive F, and the negative to the negative F. here armature voltage, the negative to the negative A, the positive. Now since we need to control our motor, our DC motor with the armature, we need to connect our armature voltage to a resistor. So for our resistor we need an RLC branch. We double click it, we remove RLC, we go to R. You can put any resistance you want, you can put 10 ohms, click OK. We connect our resistor to our armature voltage source and to the positive A. We connect the output of the DC machine to the DEM-UX. We connect the first one to the gain, because the first one represents the speed of the rotation. The second one, it represents the armature speed. The third one represents the second one represents the armature current. The third one represents the field current, and the fourth one represents the torque. Now we have created an armature speed control of a DC motor. That's the Simulink diagram for it. So now we need to put a power GUX, because we can't power GUI, because we can't run our simulation without this one. So we put it here like this. We need to reduce our stoppage time probably to 0.02. That will be enough for us to see our results. If we double click the motor, this is the field type which you want. You can change any field type depending on your question. You can change the DC voltage as well. Here you can change the DC voltage as well. So this DC voltage connected to the armature inputs A plus and A minus is called the armature voltage, and this DC voltage connected to the F is called the field voltage. This is the torque which controls the speed of the rotor of the DC machine, and this is our display, which is in form of scope. So if we run our simulation and double click the scope, you will see these results. So if you want to separate the graphs, you can go on the view, you can lay out like this one, you run the simulation. So this is the speed in RPM, armature current, right? This is the field current, because there's no effect on the field, right? There's no effect on the field, there's no resistor, no what. So the field current remains constant like this, and this is the torque, right? So that's all. This is how you can change the speed of a DC motor by changing the the value of the torque or changing the value for resistors. So this is how you can make a diagram on the Simulink or a simulation on the Simulink about armature speed control. Thank you for watching. Make sure you click like button and subscribe to my channel. Thank you.